We are given a question under motion under gravity, a question of motion under gravity. Motion under gravity. Now let's go on to the question. In the question we are given that a palm fruit dropped to the ground from the top of a tree, which is 45 meters tall. Now in this our question, we are going to imagine some imaginary vision. So we are told that a palm tree. So let's have a tree. Okay. So this is a palm tree, and on the palm tree we have a palm fruit. So this is the ground level of the palm tree. So it dropped to the ground. That means the palm fruit, which is on the palm tree, dropped to the ground, and the height or at which it dropped to the ground is the height of the palm tree, and that is 45 meters. So going on with the question, it says, how long does it take to reach the ground? So the question is how long. That means anytime you use the word how long in physics, how long usually refers to as time, and anytime you use the word how far in physics, how far usually refers to as distance. So the question here says how long, so we have to find our time. How do you solve question like this? The way you solve question like this is obeying the parameters that are in place anytime you are dealing with motion under gravity. Now let's consider those parameters that are in place. Considering those parameters that are in place, we have that let R1 be the ground level, and we have our maximum height to the other side. And we have a boy that tries to throw probably an apple directly or vertically upward. And when the ball throws the apple directly or vertically upward and get to the maximum height, there are some parameters that are actually in place. The very first thing is that when the boy throws the apple vertically upward, it has what we call initial velocity. And the initial velocity is at maximum. And what does that mean? It means the initial velocity can be at any value. But when the ball throws the apple, it's going to get to a point at which the apple is going to come to an halt on the space. When it comes to an halt on the space, that is where we have the final velocity. And the final velocity becomes 0 meters per second. And before you know, acceleration due to gravity begins to bring down the ball to the ground. So when it's bringing down the ball to the ground, it's still at the top. So in that case, we have our initial velocity to be 0 meters per second. And when it drops to the ground, our final velocity is that maximum. Please and please, you have to know these parameters very well. Note that anytime an object is thrown vertically upward under the influence of gravity, the initial velocity is at maximum, while the final velocity is 0. But when it's coming downward under the influence of gravity, the initial velocity is at 0, while the final velocity is at maximum. Another thing you need to consider is when the object or the ball, the apparatus, is being thrown up, the gravity was not supporting it. That means we are going to have negative G, and when it's coming down, gravity was supporting it. So due to because of that, we can gain our formula. The first formula says that V equals to U plus or minus GT. That's the first formula we have under motion under gravity. Another formula says H, now not your F. H equals to UT plus or minus RGT square. And the last one says V square equals to U square plus or minus 2GH. Now have this in mind. Why do we have our plus or minus, our plus or minus, our plus or minus? The reason is because the value of G can be positive, or the value,